Hello students, we will continue the lesson units and measurements. The article name is rounding off the numbers. Okay, so how to round off the numbers? They will specify the digits to which you need to round off the number. Let us go for one simple example. So the number given over here was 18.35, and what was the question? You are asked to round it off up to 3 digits. So how to round it off up to 3 digits? As you know, 18.35 has how many significant figures? 1, 2, 3, 4. 4 significant figures. But you are asked to round it off to how many digits? 3 digits. Means I have to drop 5. Okay. But how to drop 5? Just see the preceding number. Whenever you are deciding to drop 5, that is the ending number 5, just see the preceding number. If a preceding number is odd, increase it by 1. If the preceding number is odd, increase it by 1. If the preceding number is even, retain the number. But this concept comes only when you are about to draw ending number 5. So now 18.35. Now I have ending number 5. Now I have to focus on the preceding number. That is 3. Even or odd? Odd. What is the rule? Increase it by 1. So you have to draw 5. Preceding number is odd, so you have to increase it by 1. Therefore, answer for this is 18.4. Just see the number of significant figures over here. 1, 2, 3. Because what is the task given? Round it off to 3 digits. So this is how we have round it off to 3 digits. Now coming over to this. Just see the same story. Here also you are asked to round it off up to 3 digits. Presently how many digits? The number has 4 significant figures. Now I have to drop the ending 5. But just see the preceding number. So if ending 5 was about to drop, when you are focusing on the preceding number, if it is even, what is the rule? Retain it. Therefore, for this answer is 18.4. And check the number of digits 1, 2, 3, and that is how the task is completed. So this is the 18.45. When it is rounded off to 3 digits, the value will be 18.4. Now next question, 12.653. So how many significant figures the number has? 5. Now you are asked to round it off to 3 digits. Means that I need to remove this 653 where it is approaching towards 700. Therefore, when you are rounding the number, the answer will be 12.7. Just see the number of digits involved over here. 3. 1, 2, 3. Agree? So now, just see this new number. 248337. So you are asked to round it off to how many digits? 3 digits. So I have to remove this. It is less than 500 now. So when it is less than 500, what I should do? I have to go for the lower one. So for such a question, such numbers, the answer is 248000. As you know, if you were ending the numbers, the number ends with a 0, then all of you have studied this comes under the number ending zeros are not significant. So therefore these are not significant. Therefore how many digits, how many significant figures? 24800 has only 3, because ending zeros are not significant. Now coming over to the next one. 101.55 into 10 raised to 6. And all of you know that the raise is not taken into account for significant figures. Now what is the task given here? Round it off to 4 significant figures, that is 4 digits. But here already 3 are there. I have to round the 0.55 to 1. So how I should round? So where it is approaching? Towards the 60. Therefore, your answer would be 101.6 into 10 raised to 6. And now how many significant figures? The number has 4. Okay. Okay students, the next article is related to instruments, that is accuracy. What does the term accuracy stands for? It refers to the closeness of measurement to the true value. It refers to the closeness of measurement to the true value. What is the true value? This is the value, we can call it as a standard value of reference. Okay. So it refers to the closeness of measurement to the true value of a physical quantity. We refer as what? Accuracy. So for example, the standard value of a measurement for acceleration due to gravity is how much? 9.8 meter per second square. So when you are in the lab, you are going for different trials, and why you repeat a number of trials over there? Just to approach this true value, which we refer as a standard value. So how close are the closeness of measurements to the true value? Then your accuracy rate will be high. So that is why we can say that in simple words, in your experiment, if your error is less, then what is more? Accuracy is more. Just see, less is error, more is what? Accuracy. So next, your instrument must have another important quality called precision. And please remember, this is the precision is related to instruments only. So it all includes how you design an instrument. When you improve the design, so precision will be more. First of all, what is the precision? The limit to which the quantity is measured. So that limit is decided by whom? Of course, the instrument. That is the precision. One more time. The limit to which the quantity is measured is called what? Precision. And every precision depends on what factor? Least count. Your meter scale has what least count? Please 0.1. Whereas vernier calipers has a least count 0.01 centimeter. So precision refers to what? The limit to which the quantity is measured. Now, how you improve the precision for an instrument? Very easy. Less is the least count, and what is corresponding will be more? Precision is more. Let us move for some example that will differentiate these two terms. Okay. Some illustrative example. Let us say the true value. True value. Just an example I am giving. True value of mass is 0.520 gram. This is the standard value of reference. And the students are asked to conduct experiments so that they can compare their value with this true value. So when student A reports the value 0.52 gram, student B reports the value 0.516 gram. Then student C reports 0.521 gram. Just see, the student A reported 0.52. Our true value for the experiment given was 0.520. Now see whether this student has approached the standard value. No. So therefore the value is not accurate nor precise also, because see that the digits, it has 1, 2, 3, but it is able to round it only 2 digits only. So it is neither accurate nor precise. Now coming to this, just see 0.516. He has some precision, but still he is not accurate. Precision he is able to maintain, but accuracy still he is lacking. Now coming to this, see, both are matched here. Precision, because up to 0.520 he was able to reach, and accuracy, just see the accuracy. The standard value given is 0.520, what he estimated 0.521. So this will help you to differentiate the two terms, accuracy and precision. The first one, neither accurate nor precision. Second one is precision, has a precision but not accurate. Third one, both accurate and having precision. Okay. Okay. So we continue. Another term we often use in laboratory, that is error. What is error? It is the difference between the true value and the measured value. What is the true value? True value in the sense the standard value evaluated by the scientific community, or that standard of reference we call as a true value, and the measured value that you evaluate by conducting several trials. So the difference between the true value and the measured value, we take it as the term called error. There are many types of errors. So just we have listed out them. One is called a constant error, as the name itself indicates, constant error. Second one is a systematic error. So these errors are related to the instruments. Sometimes you may be given faulty instrument, that may cause what? Systematic error. So these are instrumental error, and in this some personal errors are also included. Okay. Then the least count error. The instrument, every instrument has some least count. If you are selecting the instrument with more least count, then the precision will be a problem. So therefore this may also cause some errors while measuring. This is called least count error. Next one is a random error. So what are random errors? Just see, the errors which occur irregularly, because the name random, the errors which occur irregularly and at random in magnitude. The values of them is also random, not only in magnitude but also in direction. These are grouped as what? Random errors. One more time, what are random errors? The errors which occur irregularly and at random in the magnitude and direction are called what? Random errors. Now, how to eliminate random errors? How to eliminate random errors? By repeating the experiments or taking the different trials for the same experiment given. So when you do this, then we have two more quantities to be discussed. One is called the true value. So while taking a number of trials, when you go for arithmetic mean of all measured value, that becomes what is known as a true value. Just see how it is represented as A bar. The arithmetic mean of all measurements, means trials you may say, all measurements is called what? True value. Let us take you have measured the individual values in an experiment with notation A1, A2, A3 and so on. Okay. Then how you write the true value for the experiment is true value is equal to individually measured values A1, A2, A3 and up to AN. So here the number of terms involved is n. Therefore it is divided by n. For example, if you are taking 3 trials, then how do you find the true value for the 3 trials? Very easy. You have to add 3 trials value divided by 3. That will give you the true value in that experiments. Next, we move on to the absolute error. Please remember, these are the concepts developed only to eliminate what type of error? Random error. Next one is absolute error. What is absolute error? Just see, the magnitude of a difference. Just to focus on the word magnitude of a difference. We focus on magnitude part. Magnitude of a difference between true value. True value means what? The mean value or the arithmetic mean of all measurements. Okay. The true value and individual measured values. One more time, the difference between the true value. True value means the average value of the experiment and the individual measured value. Just see, the first absolute error delta A1 will be true value minus first value, first individually measured value. Second absolute error will be true value minus second trial taken. So like this. Okay. So next we move on to the one more concept, mean absolute error. Another one is mean absolute error. So just now we have seen absolute error. So mean absolute error means the arithmetic mean of all positive magnitudes. This you need to focus. The arithmetic mean of all positive magnitudes of all the absolute errors. Sometimes you may get a positive, sometimes you may get a negative. But you have to take modulus in the sense positive magnitudes. Okay. Because errors never get added and errors are never be subtracted. They are always added. So that is why we take a mean of the positive magnitudes of all absolute error is called the mean absolute error. Just one more you need to focus. What is a mean absolute error? The arithmetic mean of all positive magnitudes of absolute errors is called the mean absolute error. The notation is delta A bar. So here what is this? Absolute error of first trial, absolute error of second trial. But what we did? We took the magnitudes. So while taking arithmetic mean, just see the number of times the absolute errors are mentioned, n times divided by n. This will give you arithmetic mean of absolute error. So after this we move on to the relative error. What is the relative error? It is the ratio. Ratio of what? It is the ratio of what is this? Mean absolute error. What is this? True value, or sometimes it is called the mean value. So let us focus on the definition. It is the ratio of mean absolute error to the true value of a measured quantity. Therefore, how do you express the relative error? It is equal to delta A bar divided by A bar. What is the delta A bar here? That is the mean absolute error. And what is A bar? The true value. If the same is expressed in terms of percentage, then it is called the percentage error. So let me repeat. What is the percentage error? If the relative error is expressed in percentage, then it is called the percentage error. So how to express the final result? Okay. For a measured quantity, how to express the final result? Final result will include first, what is this A bar? The true value, plus or minus, what is this delta A bar? The absolute mean value. So this is how you can finalize the result. So final result should have two values. One is the true value and the plus or minus mean absolute error. So this is how you can summarize the concept of error. Okay.